Hi, so in this video I'd like to show you how to implement a producer-consumer model using Python's AsyncIO. So it's a simple technique that can be used to perform multiple tasks asynchronously. Here in this example we're going to look at something where we're executing the same task, the same function. So we're performing the same work over and over again, but just with different inputs. So for example, you might be required to make a call to some API, and it's the same endpoint. Maybe you're getting a price quote, for example, and you're just making that same, call to that same endpoint, but with different symbols, right? You're looking for price, the quote, let's say for Google, then Microsoft, then Apple, and what have you. So this is a good example of, wanting to use async, because async we use when we have concurrent tasks that we want to run that are IO bound. Because this way, while we're waiting on I/O, right, we're waiting for that response from the API, we could be doing something else like firing off another request to the same API or processing that result that we just got back from that API. So this is a good example of why we may want to use asynchronous processing in this case. But we may have too many tasks to just fire all of them off at the same time. Sure, with async you can just create your tasks, put them in, fire them off. But what if we have to execute this 1,000 times? Do we really want to create 1,000 tasks in one shot, add them to an event loop, and then run things? Probably not. We may want to limit what we're doing to maybe only 50 concurrent tasks. So we have more tasks to do than we actually have async tasks available to work with. And so for that, the consumer-producer model works really well. So a producer essentially submits work to be done to a queue. So a queue, which I'm going to call the work queue, is what handles, essentially what holds all the work that needs to be done. In our case, we're going to be using the same function. So it's really just going to be the parameters of, well, what parameters do I want to run with that same function, that same worker task? You could have multiple producers. In this example, we'll just have a single producer that's going to submit work to be done to the work queue. Then we're going to have one or more workers watch that queue. And that's, in the previous slide I said we would have, let's say, 50 of them. So you might have 50 workers, which are 50 asynchronous tasks that are basically running and looking for items on the queue. And if it finds one, it says, okay, I'll take it. And it will then do the work, right? So it grabs the item off the queue, does the work, and then that item is removed from the queue. And the other workers are doing the same thing. They're looking for an item on the queue as well. And they're going to grab an item from the queue if there's one available, do the work, and then come back and look for the next one. So those are the consumers, right? They're consuming items from the queue. The producer is putting items onto the queue. The consumers are pulling from the queue. Now, once the producers are done, right? Once the producer, in our case, a single one, is done pushing all the work to the queue, and once the work queue is empty, well, that means that everything was handled, right? The workers grabbed all the items from the queue. The producer is no longer putting anything into the queue. We're done. So we've done all the work that needed to happen. So the work here is done by some function, the same function, and just a different set of parameters each time. So we're going to have a producer task, we're going to have a work queue, and we're going to have worker tasks. The producer task is going to push items to the work queue, and the worker tasks, each one is going to pull an item from the queue, do the work, push the result somewhere else, and then come back and look for the next item on the work queue. So here's how we're going to actually implement this. So we're going to start off with the function that we want to run and the parameters that we want to run for each invocation of that function. I'm also going to define two more functions, one that's going to be called by this async system when the task is complete. What I mean by the task, I mean when the function has been called with the parameters and the work has been done, the results have been obtained. If it was an API call, we got the result back from the API, we processed it somehow, and now we have that result that's ready, basically. When that happens, we're going to issue a callback to this function here. So my main code is going to get a callback from the asynchronous consumer producer system saying, hey, this is the result for this particular task. And then I'm also going to have one when the job is completed, basically all the work has been done. So I'll have two callback functions. They're just regular Python functions, as you'll see, but they're going to get called from the asynchronous processes. And then we have this async system. So this async system is going to receive the function, the list of parameters that we want, the multiple sets of parameters, and then the two callback functions. And then it's going to set up a producer task that's going to use those parameters to essentially put them into a work queue. We're going to create worker tasks, n number of them. They're going to pull from the work queue. And here's the difference. I am not going to have the worker task call the callback for task complete. The task complete callback could be blocking, and it could be blocking a long time. I don't want to block the workers from actually doing the work. So what I'm going to do here is when the worker is done processing an item from the work queue, it's going to push the result to yet another queue. And then we're going to create some result handlers. Again, those are going to be async tasks. They're going to be basically watching the result queue. Every time a result comes in, it's going to pull one and it's going to issue that callback. So that result handler is actually the one that's going to do the task complete callback. This way, I'm not blocking my workers in case my result handlers, because of that callback, take a long time to run. So you don't have to do it this way. You could call it directly from the worker tasks if you wanted to. I just want to set it up this way. And this way we have a good example with two queues, work queue, results queue, different sets of handlers, workers, producer task. So with that, let's jump into code and actually build this. All right, so let's go ahead and create kind of the skeleton. Now I'm going to divvy things up into all kinds of different modules. And it's really just so that we can focus on one thing at a time. In practice, you may end up putting some of these things in the same module. Here, I'm just going to break it up completely. So the first thing is we're going to need a main kind of application, right? So let's go ahead and call this module main. This is the module that we're going to run in order to run this whole thing. Then we're going to need the things for the consumer. So let's go ahead and create a consumer. So let's just call the module consumer. By the way, all this code is available. If you look at the description below the video, I'll post all the links in there, but essentially it's going to be in the GitHub repo that's associated with this blog. So let's go ahead and create the consumer. We're going to need the producer. Remember we talked about the producer. So let's go ahead and call this producer. And then we also need the result handler. So we'll call that result handler. And then we also need this controller that's going to kind of kick everything off and control things, shut things down, and so on. So we're just going to call that controller, like so. Okay, so those are our main files, and we're going to need to implement them all separately. So let's start with main. So this is going to be our main module, and I'm going to switch to presentation mode so we can actually see the code that I'm writing here. And if you want to follow along, of course, just take a look at the description and look at the link for the GitHub repo. You'll find the files there as well. So this is the main module that we're looking at. So there's a few things we're going to need to import. So from functools, I'm going to import partial. Then from random, I'm going to import seed. The reason why I'm going to use seed is because I'm going to use some random numbers to do some timings. At least to simulate a long-running task, a long-running asynchronous task. I'm going to simulate that when we get to the consumers, the workers, and so I want to have it to be repeatable, so I'm going to set my seed to some fixed value. I'll use 0. This means that we have consistency from run to run. And then from UUID, I'm going to import UUID4. I'm going to need that when I create my job. So then let's go ahead and start writing this. So def main. And this is where I get the squiggles. From that, import UUID. Okay, so let's go ahead and create the job ID. That's going to be just a string. And I'm going to use type annotations here. And this is going to be none. And the first thing I'm going to do is just print this out, saying I'm starting a job. And let's go ahead and interpolate job ID in there. I also need to define those callbacks. Remember those callbacks that we talked about? So I'm going to go ahead here and define them. So let's go ahead and call it def task completed callback handler. And it's going to take as a parameter the job ID. I'm going to want to know which job ID was this for. And I'm also going to need to know the callback message. So I'm here going to use a just generic dictionary. So let's call it callback message. And that's just going to be a generic dictionary that's going to be passed back to me from the worker tasks, right? From the workers that are running. And this isn't going to return anything. It's just going to be none. And here, I'm not going to do much with this. I'm just going to print basically the fact that the task completed. So task completed in, let's say, job ID equals job ID. And we're going to also print out the callback message. So we'll do callback message equals like so. That's all this function does, right? Now, the next thing I want to do also is the job completed callback. So let's go ahead and write that. So job completed callback handler. And again, I'm going to want to know what the job ID was that just got completed. And I also want to know what the callback message is. I'm going to expect to get the callback message, I should say. Dict, and that's going to, again, be a none for the return type. And we're going to basically do the same thing. We're just going to log to the console that the job, and let's say job ID completed, and then we'll also put in the callback message, like so. So those are our two functions. And now we're going to implement the remaining part of the main thing. So now we need to define those callbacks. Now, they're defined, but what I want to do, and why do I have a squiggly here? Oh, no new line at the end of the file. Fine, there we go. And this one is because there's too many lines in between. Okay, so we have those functions defined, but you'll notice that I have the job ID. Now, I could pass the job ID into each task and pass it to the whole, async thing, but I actually don't need to. What I could do here is I could actually query job ID as part of my callback. And so this is why I use the functools partial. You could also use a lambda to do the same thing, but I'm going to do it this way. So I'm going to define my callbacks by querying the job ID. So I'm going to do cast callback equals partial. I'm going to partial what? I'm going to partial the task completed callback handler, that function. I'm not calling it. I'm just using that function. And I'm going to pre-populate essentially the job ID. Then I'm going to do something, same thing with callback for the job. So job callback equals partial. Let's call it job completed callback. Again, I'm not calling it. And now I need to go ahead and define my data that I want for each task that I'm going to run, each instance essentially. So task data equals, and I'm just going to create a dictionary that's going to have the task ID. That's going to be I. We'll define I in a second. And then we will do a number. Let's say this is the data. I'm just going to have a simple task that just squares that number, right? Multiplies it by itself, essentially. And we'll do this for I in range. Let's go ahead and just use 10 to start off with. So here, basically what I've said is I have 10 units of work to do, right? I've got the task ID and the number, and that's what the workers are going to process and, give me back the results. Once I've got that, I now need to start the job. So what I'm going to do here is I'm going to assume that from the controller, I have a function called run job. Now, this is not an async function. It is just a regular function that's going to set everything up, do the asynchronous work, handle the queues, the messages, and all that stuff. And it's just called run job. So that's all I have to do here. I have to do run job. Now I'm going to need to pass it some things that it needs to know. It needs to know what's the task data. So we'll pass it the task data, right? This batch essentially of work. It needs to know what the callbacks are. So I'll pass it the task callback, this curried one, right? The partial. And I will also need to pass it the job callback. That's it. So that's what our main looks like, right? We still have to, of course, implement run job. Hence, it doesn't exist yet. Okay, so now that we have main, now let's go ahead and do some of the other ones. And let's go ahead and before we write the controller, let's set everything else first up. So the first one I'm going to do is the result handler. Let's go ahead and do let's do the producer. Okay, let's start with the producer. Again, let me just switch to presentation mode for that. So we're going to need to do a few imports. So let's import AsyncIO. And let's go ahead also from typing import list. Since I'm using type hinting here, we'll need that. And now we need to define our producer. So let's async def. So this is an asynchronous function. Produce work. And what does this thing need to know in order to produce the work? It needs to know what that batch of data is. So here I'm just going to call it batch. And it will be a list of dictionaries, right? That's what we were creating in the main module. So it's going to need the batch. It's going to need what else? Well, it's going to need the work queue. It needs to know what to push to. Now the type of this is an AsyncIO queue. So this is an AsyncIO queue, not just a regular queue. It's an async queue. So it also needs to be able to tell the controller that it's done producing work, right? So we need to tell it that. And so we're going to use an AsyncIO event object to do this. So we'll go ahead and call this producer completed, and that's going to be an AsyncIO event. And that's it. That's really all we need to define the producer. So what is this producer going to do? Well, it needs to take all the data, all those dictionaries that we have in that list in the batch, and push them onto the queue. So that's very straightforward. We're going to say for data in batch. So now data is that dictionary that contains the task ID and that number. And then we need to add it to the work queue. Now the queue is an async queue, and you don't just add an item to the queue, you have to await it because it is async. And you'll see why when we go and look at the controller. So, well, first of all, async queues, you have to do that. But why do you have to do that? Why use an async queue for this? Well, this way I can limit the size of the queue. And what will happen is that if the queue gets too full, then whatever's pushing into the queue, like this producer here, is going to wait until it can. Basically, until the queue clears up a little bit, then it can start adding things in. So that's one of the things that we can do now, is we can actually define the size of that queue. Okay, so now when this is done, when this is finished, when we reach this point in the code, we're done. We've produced everything that needed to be produced. So now we can use that event to basically set it to say we're done. So completed, and we're going to use the set method on that. That basically sets the producer completed to true. You can think of it as a flag called producer completed. When we create it, we'll set it to false, and then here it will get set to true. But it's an AsyncIO event object. And that's it for the producer. It's very straightforward, right? We read items from the batch, from the regular list, and then we push those dictionaries onto the queue, and then we indicate that we're done. Okay, so the next one that we can look at now is going to be, let's say, the consumer. We're going to write the consumer. So let's switch to that. So let's go to the consumer module, and let's switch the presentation again. So again, we're going to need to do some imports. So we'll import AsyncIO, of course. Then from random, we're going to import random. So this is where I'm going to use random times to simulate, kind of tasks that take a little while to run. And then I'm going to want to time things to know how long each task takes to run. So from time, I'm going to import perf counter. Okay. And let's go ahead now and write our worker. So this is going to be, again, an async function. So async def, and we're going to call this one, let's say, do work. And what does it need to know? Well, it needs to know the work queue because it's going to pull items from the work queue. And again, the type of this is an AsyncIO queue. It's also going to need to know what to push to. So result queue. It's going to need to know that as well. And I'm not actually going to, you notice that I didn't define a work function, the function that actually does the work, like maybe does the API call and so on. I'm just going to bypass that, but you know, in real life, you would have to probably define that function somewhere, and then this do work would call that function to do the work. Either you pass it in as a variable, or you could just import it into the module, right in here, and then actually use that. But that's going to be, something else that you'd want to implement. And of course, you're going to want to make sure that you implement it as an async function as well. So if you're making an HTTP call, you're going to want to use asynchronous versions of those kinds of things. Okay, so we've got this now defined for the parameters, and let's go ahead and set this up. So what does this thing do? Remember, it's supposed to basically wait until it gets an item from the queue, take the item from the work queue, process it, and add the result to the result queue. So this means that this function is going to run indefinitely. So we're going to put an infinite loop in here. This function is not responsible for stopping itself. The controller is going to do that. So this is just going to run indefinitely. It's just going to keep looking for items in the work queue and process them as it gets them. So how are we going to get items from the queue? Well, we have to use the work queue, and this is going to be an await. So it's going to wait until it can basically get an item off that queue. So now we've got an item off that queue. What do we have? Well, we have that dictionary, remember, that has the task ID and the number. So just to make it a little clearer here, let's go ahead and pull out those from the dictionary. We also have the number, which we know is in the number key in that dictionary. Now we need to do some work. So I'm going to simulate the work here, but I also want to time how long it takes to run. So I'm going to probe my perf counter. Then I'm going to do a sleep. And it has to be an asynchronous sleep, just like you would implement your function that's going to do maybe your API request as an asynchronous function as well, because otherwise it's blocking. There's no point in doing any of this stuff. So we're going to do our AsyncIO sleep, and I'm going to sleep a random number of seconds, up to 2 seconds, like so. And this is why I put seed in the main module, just so we have repeatable waits whenever we run this application. Okay, so we've got that, and then if we were to call this function asynchronously, we would also get a result back. And so we would be able to get our result, and here I'm just going to mimic that our result is just the number squared, like so. And now I'm going to say end perf counter is equal to perf counter. So I'm going to see how long it actually took to run the task. So now the work is done, I have to push the result to the queue. So again, we're going to use an await, but this time we're going to put to the queue. Just like the producer was putting to the work queue, it had to use the await. We're going to do the same thing. We're going to put that onto the result queue. Again, the result queue could be limited in size, so we're going to have to wait until we can actually put it into that queue before we can continue. And as we're waiting, of course, because it's asynchronous, some other task could be doing some work at the same time. Or instead, since we have concurrency, not parallelism. So what do we want to return in the message? Here's going to be the result. Basically, it's going to be the task ID. We're going to have the result, which is going to be the result, which is the number squared. And then we'll also pass back the time in seconds, like so, which is end minus start. That's it. So now what did we do? We've pulled an item from the queue. We've processed it. We've pushed an item to the result queue. We now need to tell the work queue we're done with this item. And we do that by calling the work queue task done method. That's a method that queues implement in async. So this basically says, I'm done with this. And that's it. That's our worker, right? So our task has been defined. It's going to run indefinitely, and we're going to create multiple instances of this do work, right? We're going to have many running at the same time, but each one is going to run indefinitely and basically just grab items off the queue. So now that we have that, so we've got the producer, we've got the consumer, let's go ahead and write the result handler. So let's switch to the result handler module and implement that. So again, we need to do some imports. We're going to need AsyncIO, and since I'm using type hinting, I'm going to import from typing. I'm going to import callable because we're going to have some parameters here are going to be functions. Well, one parameter is going to be a function, so we'll need to use the callable from typing to do the type hint. So again, we're going to create our async function, which is going to get called handle task result. What does that need to know? Well, it needs to know what the result queue is because it's going to grab items from that queue, which is again a AsyncIO queue. It also needs to know the callback. What is it going to call back? Remember, it's that function, that task callback function that we defined in the main module. We're going to need to pass it to this task over here, to this async function, because it needs to know what to call back. And what was that? Well, it was a callable. What were the arguments to that callable? Well, it had two. Remember, it had the job ID and the data itself, the dictionary, but we curried the job ID. So in fact, when the callable gets called, it's only going to receive the dictionary. So it's only going to have a single variable, which is going to be the dictionary, and it doesn't return anything. So it's going to be none here. So now that we have that, we need to handle the results in the result queue? Well, it's going to be the same thing as what we did with the consumer, with the worker, right? The other consumer. This time we're consuming the result queue. So it's going to run again indefinitely, and it's going to get the value from the queue. So we're going to await result queue.get. So we're going to wait for a result to pop up on that queue and then grab it. And then we're going to issue the callback function, like so, right? So this is the callback, and we're going to pass it that dictionary that is on that queue that we just grabbed. And again, just like we did with the task itself, the workers, we need to tell this queue that we're done with the item. So result queue, and it's going to be task done, like so. And that's it. We're done now with this one. So the result handler is done as well. So finally, it's time now to put everything together. And for that, we're going to switch to the controller module. So let's switch to the controller module. And again, we need some imports here. So let's go ahead and import AsyncIO. Then we're going to want to say from time import, because again, I'm going to want to time now the job itself, the overall thing. So I'm going to need perf counter. Because of the type hinting, I'm going to need to import a few things. So we'll import callable and list from typing. And then we need to import our own modules. So now we need to import consumer. We need to import producer. And we also need to import result handler. Now there's going to be a few kind of configuration parameters that I'm going to do to control how many workers do we have, you know, how many result handlers do we have, what are the sizes of the work queue and the result queue. So instead of hard coding those numbers, I'm going to put them here as constants, and then we can easily tweak them. In practice, you'll probably end up putting them either in a config file somewhere or maybe in a database, you know, wherever you're storing your configs. So here, I'm going to define the value num workers, the variable num workers. Let's say we're going to start with maybe, I don't know, 5 workers initially, and then the work queue max size, let's go ahead and make that, I don't know, let's say 20 items max on that queue. So things will start waiting, right? If we have 1,000 items we're pushing through and the workers aren't keeping up, at some point the work queue is going to max out to 20, and then the producer is going to stop being able to put things. It's going to wait basically until it can put new things onto the queue. And it's going to wait for what? For the workers to remove the items from that queue. And then we want to do the same thing with the result handlers. So again, we wanted the ability to run more than one result handler. So we'll set a max value for that. So let's go ahead and set it to 5 as well. And let's call it result queue max size. And that's going to be equal to, let's say, 20 as well. And then we'll tweak those numbers and see how things change. Okay, so now we need to write this run job. Remember that we had that in the main module. We assumed that we were going to have this def run job. What does it need? Well, it needs the batch, which was a list of dictionaries, right? That's what it was going to receive. It was going to receive a callable for the task complete, task completed callback, which was a call-able. I'm not going to go ahead and define what the actual argument signature is. You can go ahead and do that. You saw how to do that when we did the result handler, right? It's the same thing there. So job completed callback. Again, that's just going to be a callable, and this thing again doesn't return anything. So just a none. It returns something, but the return type is none. So this is the main thing. Now this is not an async function, and we don't want this to be an async function because our main module is calling a regular function, not an async function. I want it to be so that the main module doesn't care about the implementation of run job. So run job is a regular Python function, but it is going to go ahead and do something to kick off an async process. And so we're going to write another function. Let me pass for a second here. And let's go ahead and actually write our controller, which is going to be an async function. So let's go ahead and write it. So async def, and I'm going to call it _controller, just to indicate that this controller is actually private really to this module, or pseudo-private since it's just a convention. What does it need? Well, it needs the same thing. So I'm just going to copy this over here, right? Like so. So that's what it's going to need. It's also not going to return anything. So if that line's getting a little long, you could just break it up this way. and it's going to do something. Let me again pass for a sec here, and let's go ahead and go back to this run job and actually now start off the controller. So this controller is an async function, so we need to use AsyncIO to run this async function. So we're going to say AsyncIO.run, and we're going to run the controller, right? We're going to call the controller, and we're going to pass it what? Well, we're going to pass it the batch that we just have, basically all those things. We're going to need to pass it the task completed callback, and we're going to have to pass it the job completed callback, right? This one over here, okay? And that's it. That's all it needs to do to actually kick off the asynchronous processing. So now let's go back and finish up our implementation of controller. So the first thing I want to do is I want to time the overall time that it takes. So to run everything, so I'm just going to probe the perf counter, call it start. Now we need to create those queues. So we need to create a work queue, and we're going to use an AsyncIO queue for that. And remember what I said, we were going to limit the size of the queue. So we'll use the max size argument, and that will be the work queue max size, like so. Then we also have a result queue, which is the same thing. It's an AsyncIO queue. And again, max size is going to be the result queue max size, like so. So those are the queues created. The next thing we need to do is to essentially create all those different tasks that need to be happening. We have the producer task. We're only going to do one. We're going to have the producer task. Then we're going to have the worker tasks, the ones that are actually going to do the work that we implemented. And then we also have to, spin up the result handlers. So we've got to create all those tasks themselves. And I want to keep track of those tasks. I don't want to just kick them off, because remember those tasks for the result handler and the do work function, those are going to run indefinitely. So I'm going to have to clear them up. I'm going to have to stop them once everything's done. So I need to keep track of what those tasks are. So I'm going to use a list to do that. The other thing too is that we need to, for the producer task, we need that event. Remember that we talked about that event, and the producer task is going to basically set the event to true. It's going to set it to say I'm done. And we need to be able to keep track of it in the controller. So we need to create this event. So let's call it producer completed. And that's going to be an AsyncIO event. And then we're also going to clear it. This is essentially going to set it to false when we start off. So it's going to make sure that it's set to false. So now we need to actually create the task for the producer. So we're going to say tasks.append. And we're going to append what? Well, we're going to do an AsyncIO create task. So we're going to create now an async task. So producer.produce work. And what are we going to call that produce work with? Well, we need to pass it the batch, and we need to tell it what the work queue was, and we need to give it the event. So that's going to be the producer completed event that we just defined. So that's it. Our task has been now created. We also need to create the worker tasks. And for this, we're going to do this many times. So we're going to say for range, for underscore in range, and this is going to be num workers. And what are we going to do? Well, to our tasks, we're going to append the tasks that we're going to create. And again, this is just because I want to keep track of what those tasks are. You don't need to append it to a tasks list to actually create the task. What creates the task is the AsyncIO create task function. So what are we going to do? Well, we're going to take the consumer dot do work, right? This is what we want to run. What does the consumer expect? The consumer, if you remember, that was expecting the work queue and the result queue. That's all it needed, because the work that it had to do was kind of embedded in that function do work. So that's all that needs. So that's that. And then we need the result handler task. So we're going to do the same thing basically for that in range. And then this is going to be the num of result handlers. We're going to do that this many times. And what are we going to add to our tasks list? Well, we'll do AsyncIO dot create task, just as before, but this time it's going to be the result handler dot handle task result. And what does that need? Well, that needed the result queue. It also needed that callback function, which was the task completed callback that we received when this thing kicked off, right? The controller got the task completed callback. Okay, so now we need to go ahead and wait for things to happen. So first is we're going to await the producer completed. So we're going to wait for that to finish, essentially, right? This is the event, the producer completed. We're going to wait for that to be set to true, essentially, that, hey, I'm done. We also need to await the work queue and make sure that that's finished as well, that that's empty, essentially. So we're going to await work queue.join, and then we need to make sure also that the results queue is done, is empty. So again, we'll just use the join method here to watch for that. So now, if we've reached this point in the code, we're done, right? The producer completed event was set to true, the worker queue is empty, the result queue is empty. So now that that's done, we can cancel those running tasks. And the tasks list contains all the running tasks. The producer should be done. I added it in there as well, didn't need to, but it doesn't hurt. So now I just need to iterate through all the tasks. For task in tasks, and I'm going to cancel those tasks to say, hey, shut down, you're done. Okay, so that stops everything, that stops the processing. And at this point, I can now use my perf counter to see how long the entire job took to run. And I can also issue my callback. So I'm going to do my job completed callback, and I'm just going to pass it a dictionary with elapsed seconds, and that's going to be end minus start, like so. Okay. And this is our program. Okay, this is it. This is the controller. And now we've implemented every part. So now let's switch back to the project view and let's actually run this. And if we didn't make any mistakes, it should run. So let's try it. So let's go ahead and run this. And we've got an invalid syntax here. So I did have a typo. Result queue. Yeah, that should be AsyncIO.queue. So we have that. Let's try it again. And it finished. It didn't do anything. Why not? Well, let's go back to the main function. And we actually haven't defined anything here to run, right? This is just the main function is defined. We have to call it. So let's go ahead and I'll switch back to presentation mode. We need to implement that. So we're going to say if name equals main. So if we're running this module, then we'll set our seed to 0. That's the first thing I want to do, just so I have repeatable wait times, right? Sleep times. And then I'm just going to call the main function. I need to build a job ID. So this is why I imported the UUID4 function. I'll just create that, pass that in. Okay, so now when we run the main module, it should run this code. That's going to call the main function. That's going to call run job. That's going to call the async, and that's going to kick off essentially the whole async process. So let's try it. And let's see if this time we have better luck. And good, things are running. Okay, so we had 10 things and they ran. You can see that it took, you know, half a second, 0.8 seconds, 1 second, and so on to run. And my job complete here is not good. I must be, yeah, see, I have the F inside the string. So let's try running this again because I want to know what the overall time is for the entire job. So as you can see, it took like 2.6 seconds to run the entire job, those 10 tasks. If you were to add up all this stuff, I mean, there's 1, 2, 3, 4, 5, at least 5 seconds. So you can see where the concurrency with the asynchronous processing really helped when we had things that were IO bound, where, you know, we weren't limited by CPU, we were limited by time waiting on something else to happen. And that's where asynchronous becomes really useful. So now we can go ahead and tweak things a little bit. Let's switch back to the controller. And you see where I have set the number of workers to 5. I'm going to set it to 1 and let's see what happens. And you can play around with all these different settings. But when we run this, you'll see that there's only one worker task running at a time. So basically, everything's going to get done sequentially. So you can control exactly how much concurrency you have. So here, it took the full 10 seconds because it had to do each one of those one after the other. Now, if I go ahead and set this to, let's say, maybe I want to have 50 workers, maybe I want to set my maximum queue size to 200, 5 result handlers, and maybe 200 for the result queue. That should be fine. You can play with those numbers. Now I'm going to switch back to here and let's go ahead and run 1,000 of these. Okay, so this is going to be 1,000 tasks, and let's see how long it takes to run. I'll pause the video. It's going to take a few seconds to run, so I'll pause the video and then come back once it's finished running. So you can see it's running. I'll be back in a sec. All right, so finished running. Took 21 seconds to run 1,000 of these. Obviously much faster than if you had serialized it. And of course, you can make things maybe more performant by increasing the number of workers, but you have to remember there's going to be a kind of a trade-off between how much memory you're using, how long your wait times are. I mean, at some point, you're just not going to have enough wait times for additional workers to really make a difference. So it's kind of up to your system and what you're doing. And that's it. That's how we can implement very simply a producer-consumer model using AsyncIO, using queues, async queues in Python. Thanks for watching.